Hi, this is going to walk you through the practice meta-analysis problem and prepare you for the meta-analysis assignment that you're going to conduct and turn in for a grade. So I want you to start with downloading the practice meta-analysis problem from your Canvas course shell. It looks like this. The assignment, this practice meta-analysis problem, is using the meta-analytic calculator Excel sheet posted in the course. You're going to calculate the average of the effect sizes for 4 different studies. The first one has a D reported of 0.89 with a sample of 100, R of 0.151 with a sample size of 60. The third study reports a phi of 0.45 with a sample size of 30, and the last study reports a D of 0.50 with a sample size of 75. The hint for this assignment is that the phi is a correlation coefficient, so you can treat it just like an R when you do these calculations. So F equals phi equals R. So include your calculations in the answer to these questions. You're going to calculate the effect size for each study. You're going to input the z-scores and the n's for each study to get the weighted average z. You're going to use the chi-square formula to calculate heterogeneity. You're going to look up this chi-square with 3 degrees of freedom in the table. You're going to use the z-test formula to calculate the test z and use the z-table to get a p-value. And then the last step is use the formula to determine the number of studies that would be required to invalidate the significant p-value obtained in step 3. So that's the assignment. Next, I suggest you download the meta-analysis how-to worksheet, which describes each step along the way, and you can follow along and compare your findings to what you see on this sheet with the answers in each step. And then the final thing that you're going to need, the thing that you're going to use to actually do the calculations, is a copy of the CNRS meta-analytic calculator. And that's how you're going to get these calculations done. So let's jump right in and walk you through doing this assignment. So let's zero these out for starters so you can start with a fresh template here. And so we said you're going to have 4 studies in this particular assignment. And those 4 studies are going to consist of findings reported in different ways. And those findings are going to be reported to you that study 1 has a test statistic D reported at 0.89. So if you go up here, it says you can input the R, input the D, input the Z, or input the odds ratio. So for study number 1, they're reporting a D. So we're going to go right here, and we're going to input 0.89 because that's what they told you the test statistic was. And that gives you your Z test statistic for that study, or the effect size for that study is 0.43. So let's go down here, and for study number 1, we're going to say that the study Z, or effect size, was 0.43. Now the next study that they talked to you about, they reported an R statistic. So this first calculation up here is what you use to input R's. So it's 0.51, and that gives you a test statistic, a Z, or effect size, of 0.56. So for study number 2, your effect size is going to be entered as 0.56. The third study they talked to you about, they report the findings with the phi. And remember, we said the phi is equivalent to an F statistic or an R statistic. So again, we're going to go up here where it says we can input the R, and we're going to input that phi score. So 0.45. And then we'll calculate the effect size, and that effect size is 0.48. Now, the last study that they talked to you about is reporting a D, and that D score was reported as 0.50. So we'll put 0.50, and the Z score we'll get from that is 0.25. 0.25. Okay, so now you've completed step number 1. You've used the calculators to convert all of these findings to effect sizes. We now have effect sizes for each of those 4 studies, and here they are listed. The other thing that's important when we're looking at a meta-analysis is not only what was the effect size for that study, but what was the sample size. So we want to input the sample sizes. So remember, we said for study number 1 it had a sample of 100, and certainly a strong effect size with a large sample makes this a bigger impact on the meta-analysis. So study number 2 had an effect size of 0.56, but it only had a sample size of 60. So we enter the 60, and we come up with a weighted Z that's actually less than the study with 100, but the lower effect size. So you can see how these two things work together to give you the weighted Z. In our third study, we had an effect size of 0.48, and the sample size was 30. So this was a small sample, and when we calculate then the weighted Z, we get 14.4. And then the final study had the effect size of 0.25 and a sample size of 75, and the weighted Z then would be 18.75. Now the next step is for you to calculate the average of those Z scores. So you're going to take these weighted Z's, your 43, your 33.6, your 14.4, and your 18.75, add those together, and you get 109.75. Divide by 4, and you get 27.4. So your average Z-score is going to be 0.27. Now you're ready to move on to step 2, and you're going to use the chi-square formula up here to come up with the heterogeneity. And you're going to look up that chi-square with 3 degrees of freedom in the table and see that in this case p is greater than 0.5, which is good, which means that there's not inconsistency between these studies, that they are heterogeneous, and they are reporting consistent findings. The next step then is to use this Z-test score, and you're going to look up that Z-test score in the Z table to get a p-value. And in this case, the Z is greater than 1.96, so your p is less than 0.05. And your final step then, step 4, is to do this file drawer analysis. And if you click right here on I-31, you'll see the formula for calculating the file drawer analysis is plugged into this worksheet for you. And so the number that appears here in this box tells you that only one unpublished study is needed to invalidate these overall findings. So you may have found overall that these were significant findings, but it only takes one unpublished study with different results to invalidate what you have done in this meta-analysis. So now take a look at, go back, now that you've done these calculations, go back and take a look at the color-coded sheet that walks you through each step so that you are familiar with how you came up with each step along the way. And then we'd like you to do the same thing in the real assignment to turn in to be graded. Good luck and best wishes on finishing it up.